Okay, there are three problems that I would like to go through with you on the homework. The first one is this question number 9 on the first page. Now, we should remember that in our setup, right, the formula we had to know from last week was when we had either a sine or cosine graph, right? Oops, plus, so we know that this A was the amplitude, and the D controlled the vertical shift, the C controlled moving left or right, and then the B value was the period length. So I'd like to look at this question and kind of come up with the answers. So first off, we need to factor out that 3 because there's only a 1 in front of the x. We need to factor that 3 out. Now if I factor that 3 out, this part here becomes 2/3 pi. Because if I multiply the 3 in, the 3's would cancel. Now the amplitude is 2. Don't say the amplitude's -2, it's 2. What that negative is going to do is to flip the graph vertically. Now the vertical shift is up 4, okay? Now, period length. This is what people tend to have a little bit of trouble with. This 3, what it tells me is, again, normally there's one cosine graph inside of 2 pi. This 3 means that there's 3 of them. So what I would do is I would break this up into thirds, and there would be one cosine graph there, another one there, another one there. There'd be 3 of them. And what we're trying to find out is we're trying to find out the length of just one of them. How long is just one of those? Again, that 3 means that there's 3 of those graphs inside of 2 pi. So here's what I do. I say 3 of the waves. Again, lambda is our science symbol. Science classes use that for the length of a wave. So there's 3 of those inside of 2 pi. That's our setup. And then to solve, well, we'll just divide both sides by 3, and we wind up with our wavelength equaling 2/3 pi. Okay, feel free to pause it. I'm going to move on to 2 other questions. Okay, the next question I want to look at is this one in the bottom left-hand corner. I believe in yours, it's called question number 10. I had some numbering problems on my graphs. So when we do these and we're trying to figure out the equation and everything given a graph, the first thing we want to always figure out is what's the vertical shift? So what I would do is I need to figure out what the new sea level is. Like here's our waves, right? If these waves were to settle down, this would be our new sea level, which means that the vertical shift has been down 3, right? It's been moved down 3. And if I look at this also, I can tell that the amplitude is 2, right? The height of the wave is 2. Now, what we have to do is figure out the period length. And to get the period length, it's not too bad to do. All we're going to do is count how many waves there are. Now there's one wave. Here's another wave, so that's 2. There's 3. And hold on a second here. There's 3 waves, and then there's 4. So hopefully you can see that in fact they're, let me put the other color on there. Hopefully everyone can agree that there are 3 of those waves. Now, to figure out the period length, what we do is we say, again, that 3 of those waves are inside of 2 pi. Solve for lambda by dividing both sides by 3, and I get 2/3 pi. That's our period length, 2/3 pi. Now, we don't need that to write the equation, but I want you to practice getting it. Now, for the equation, here it is. Now, this is a graph of sine. But normally, again, sine normally goes up and then down. And you notice this one's the opposite. It's been reflected. So there's a negative in front. And the amplitude is 2, so -2 sine. How many waves were there? There were 3 waves in there. So this would be 3x, okay? And it's been shifted down 3, so -3. This would be our equation for this one. Okay, find the vertical shift first, right? Because we can tell on our sea level. Find the amplitude next. So I'm able to get my vertical shift. I'm able to get my amplitude. There's a negative there because the graph has been reflected vertically. And then the 3 is here because, well, there's 3 of those sine waves within 2 pi. Okay, I want to look at one on the back side. So feel free to pause it right here if you need to look at this a little bit more. But I want to go on to one last question. It's number 20. Now this one, I need you to graph it, right? So this is where it gets really challenging. Well, I think we can figure out a couple things. Like the amplitude, I believe, is a 5, right? That seems to make sense. And the vertical, again, we're taking the sine of x over 6, right? The vertical shift is down 2. Now, we need to find the period length. Now, remember, inside this parentheses should just be an x, right? So I should think about it as being 1/6 of the wave is inside of 2 pi, right? Because that's what x over 6 is, 1/6. Solve for lambda, and we get 12 pi. So the period length is 12 pi. Now to graph it, we need to plot those 5 points, right? So first off, I'm going to take half of it. What's half the period length? Well, if the period length is 12 pi, half is 6 pi, right? Now let's find a fourth of the period. Well, a fourth of the period would be half of the half period, which would be 3 pi. And then I think if we were to add these two things up, we would get 3/4 pi, which is 9 pi, okay? So what we do is this, to go about graphing this. First thing we're going to do is locate our new sea level. We've been shifted down 2. So there's my new sea level here. And the amplitude is 5, right? So it's going to be going up 5. 1, 2, 3, 4, 5. And then down 5. 1, 2, 3, 4, 5. I'm going to mark off our period lengths now. The whole thing, all the way out, is the full period, which is 12 pi. We know that half of it was 6 pi, and a fourth of it was 3 pi, and this was 9 pi. We've got enough to draw our graph. Now again, we know that sine goes like this. However, we have a negative, so that means we need to go the opposite way, right? So we know we're going to be going here. And in this way, I'm going to plot out my 3 times v equals 0 first. And then, again, this negative means instead of going up, it's going to be going down instead, like that. So my point has to be here and then up here. And that's our graph, okay? This is the assignment today. It is due on Friday. Don't forget to turn your weekly in Friday as well. And if you need help, come by and find me on Thursday or see me Friday before school. All right? Bye-bye.